Hi everyone. We are now going to look at the continuum of correlation coefficients and sort of really wrap our heads around this. So I have a line across the bottom of this, and this line right here is sort of my line that is my continuum. And I actually shouldn't have arrows on the end of this. I'm going to actually change this up. I'm going to just make them end right here and right here. So they don't go on forever. They end in those places. In those places, I'm going to write this one as and label it as negative 1.0, and I'm going to label this one as positive 1.0. If you are following along and you've noticed that this is maybe the exact information that you need for your notes, start taking some notes. This right here in the middle I'm going to label as 0. So let's read a little bit up here about what this is all about. This is from your book, from lesson 4.3. When points cluster close to a line with a positive slope, the correlation coefficient is almost 1. And with a negative slope, the correlation coefficient is almost negative 1. So what we're going to find is we're going to find some graphs that demonstrate this. So when the points cluster close to a line with a positive slope, the correlation coefficient is almost 1. So it means this is a really strong relationship. That could be seen in that particular graph, which I just drew on top of instead of moved. Here we go. I'm going to move it over. So I'm going to move over this graph, maybe, if I can. Let's see if I can do this. Stick with me, people. All right, here we go. Of course, this is not going to work. Sorry. Continue to stick with me. I don't mean for this to be on. Goodness sakes. There we go. Maybe I can get it to do stuff. All right, here we go. Here's my positive 1.0 relationship. That is a perfect correlation coefficient that's showing the positive slope and is very strong. A negative 1 slope would look something like this. So again, a nice negative sort of set of points. They're going down in a nice negative slope. And here is a perfect example of a negative 1.0 correlation coefficient. Points that do not cluster close to any line have a correlation coefficient of almost 0. So that means there's no relationship. If I look at all of these different graphs, this one has a clear negative relationship. This one has a negative relationship. Here's a clear positive relationship, and here's another positive relationship. This one doesn't seem to have any rhyme or reason to it, so I'd put that one at 0. That has a 0 correlation coefficient. Positive association has a correlation coefficients that are greater than 0, while negative association has a correlation coefficient of less than 0. So now we can look at these other graphs that we have here, and we can put them also on our continuum. So if I look at this graph and this graph, we can see that they're clearly negative lines, or they're clearly negative associations in the data, meaning as the x value increases, the y value is decreasing, and that's why it's a negative sloped set of data. This is clearly a stronger relationship than this particular one, so I'm going to put this one on this continuum a little closer to the strong negative relationship. And this set of data is getting more scattered, so I'm going to put this more along the lines of a weaker relationship. I already had set those ones up in a similar way over here on the right-hand side. This one clearly has a stronger relationship and goes in the positive direction than the other graph, so I'm going to put this over here on this continuum. This one is a little less strong, and so I can put it over here as well, so a little closer to the 0, not as close to the 1. So now based on that, we can also look at these in terms of, like how we could estimate their relationships. If I were to estimate the correlation coefficient of this particular graph, I would maybe call it a negative 0.9. Whoops, that's a 9. Maybe as low as negative 0.8. This relationship here, it's pretty strong. It's more strong than, say, this one, which has no relationship whatsoever, but it's not as strong as over here. So I'd maybe call this one negative 0.5 correlation coefficient. Now notice, unless I actually know what these data points are and I put them into a calculator, I can't actually be completely positive of what these correlation coefficients are, but I can put them along this continuum and sort of give a rough estimate on what they could be by saying this is what zero, this is what -1 is, this is what 0 looks like. If I look at these two ones, I can sort of place them on that continuum and sort of get a pretty good idea about where they would sort of estimatedly be or approximately be on the number line. I can see the same sort of thing with these two graphs. So I'm going to say this is a positive 0.9, maybe as low as positive 0.8, but I'm not going to go much lower than that. This particular one, it looks very similar to this one, except it has a positive relationship, so I'd say positive 0.5. Again, here's 0, here's a positive 1, here's a negative 1, and I can estimate or find approximately where these other graphs are on these on this correlation coefficient continuum that we have here. That is essentially what you want to take away from this entire unit. You're going to be looking at various graphs that'll be provided to you, and your job will be to say, what is the approximate correlation coefficient for this set of data? Does it have a strong relationship or a weak relationship? Is that relationship positive or is it negative? And then I'll ask you, like, where would you place it on this continuum? Would you say it as a -1, a -0.5, a 0, a positive 0.5, or a 1? So I'm not asking for anything super specific. I don't want you to put any numbers in a calculator or anything, but I do want you to, generally speaking, say where you think that information could lie on the line the best. Okay? I hope this helps. Make sure you complete the notes for this lesson, and then after that, work on the must-do problems and the exit pass. Thank you for watching. Bye.